Imagine a tool that would allow you to visualize your code. Imagine the possibility of extending your application at runtime. Imagine an interface so complex, yet still so transparent that even a child could use it. Now presenting Sphero, a dynamic framework for context-aware composition. Sphero is a revolutionary way of developing context-aware applications using circle packing. Circle packing is an optimization problem, where the goal is to place as many spheres within another sphere, without them overlapping each other. Sphero comes preloaded with a tutorial section to help the user familiarize themselves with the new environment. The user can effortlessly expand this tutorial by hovering the mouse cursor over the sphere, and rolling the mouse wheel forward. We are greeted by the Sphero help text presented on the background canvas. These background help text contain information about the purpose, or functionality about the current context. When traversing further into the graph, the user is prompted with more help text and instructed to expand the main menu tutorial. By using the right mouse button, the user invokes the main menu with standard items across all contexts. We will now enter the next tutorial, namely the context menu, and also the most integral function of the Sphero framework. When the user uses the right mouse button on Context Demo 1, another context menu appears. However, this context menu is different because this menu, unlike the previous tutorial, reflects only the actions allowed in the specific context of Demo 1. When the action, change color to red, is selected by using the left mouse button, the context Demo 1 is modified and reflects the changes made. When the other sphere's context menu is invoked, we see another set of applicable actions, again different from the previous. This context also allows us to add a child node, which will then become part of the entire graph. The next integral part of the Sphero framework is the observer pattern. The observer design pattern is one of many industry standard solutions to commonly occurring problems. This implementation allows a user to quickly draw relationships between spheres. Note that there are a total of 8 spheres when we add an observer. When we draw the relationship again in the same direction, the context has changed slightly, presenting another option, the removal of an observer. This option is only available if there exists a relationship between two spheres. Sub-options provide the user with more advanced controls that will be visible when the context is completely expanded. The sliding panel can be clicked with the left mouse button to auto-expand, or dragged with the right mouse button to the preferred size. These sliding panels will be automatically removed when the user leaves the context. Using all that we have learned from the previous sections, we expand the last tutorial. This tutorial is targeted at more advanced users, but can be easily done even with little or no programming skills. After we create a new sphere, we see a sliding panel on the right. Resizing this panel reveals one of the most useful functions of Sphero, the built-in compiler. This allows users to build, compile and include libraries at runtime. The result is an application that can be updated without the need for restarting your computer or closing the application. This can be extremely advantageous in mission-critical scenarios that will be later discussed in the robotics use case. When the user completed the instructions and submits the source code, a new sphere is created with the user-defined functionality. To do some post-configuration of the newly created sphere, we need to expand the parent until only the child sphere is visible. Using the right mouse button on the child sphere, we invoke its context menu. We can now select the Properties option to reveal the Properties sub-option menu. Here the advanced user has a powerful control for object manipulation. For example, the user may change the color to yellow and set the help text content. The tutorial is now complete and we will now discuss the possible application of Sphero. We will now review a couple of use cases. As we enter the Sphero use cases sphere, we are presented with 4 possible applications. Let's expand the Sphero file manager. Here we see 2 spheres, one labeled as debug folder, and the other, a date created sphere. The first sphere is an actual folder that can be opened in Windows Explorer. This is done by opening the context menu and selecting the open option. The second sphere, date created, is a custom sphere implementing the view class. This means that this sphere specializes in generating easily understandable groupings to the user or client. This specific sphere was created to demonstrate the grouping of files by extension, under experimental physics sort, where the objects are moved left and right based on their creation date. Next we look at the artificial neural network example. Let us increase the view depth, allowing us to see more of the underlying spheres by invoking the main menu and selecting the level of detail option. Select the successive increase view depth option. Now we should see the flow of data between the network layers. Although this is not yet a fully implemented neural network, it does fully utilize the observer pattern, transferring data from the independent input variables to the dependent output nodes as visualized. The physics simulation provides the user the ability to experiment with various forces that influence spheres. For example, decreasing the radius and adding weight. Now reviewing the Sphero robotics use case, we will briefly show the sensory components used in the robotic hexapod model. The hexapod is divided into many different contexts. We will now traverse through the logical structure until we find the distance sensor relating to the physical sensor. The distance sensor can be found in the left hemisphere, on the rear leg, and is labeled S11. The infrared sensor is mapped to the client area of the application. This is indicated by the yellow line, showing the distance from the surface. Heading back to the hexapod root, we can also view sensor information in the sensor's view. This view is similar to the view shown in the file manager section, grouping similar objects from different contexts together. Here we can quickly determine whether or not all the sensors are operating properly.